Hi, today I'll be going through rate law for AP Chemistry. So the first question is, if the rate law for the reaction 2A plus 3B equals products is first order in A and second order in B, then the rate law is rate equals blank. So we're looking for the rate law, which has the equation R equals K concentration of A to its order and concentration of B to its order. So in this case, it's pretty simple because they tell us the orders, first order and second order. So we know that we have to write K concentration of A to the first power and concentration of B to the second power. That is the rate law equation for this reaction. And remember that whenever we're doing the rate law, all you have to look at is the orders and ignore the entire equation that it gives you, because the molar coefficients don't count. For this form, you only care about the order. The kinetics of a reaction below were studied, and it was determined that the reaction rate increased by a factor of 9 when the concentration of B was tripled, so by a factor of 3. The reaction rate is blank order in B. So basically what you need to know about the order of reactants is that if it is first order, then if you double the reactants, the concentration or the rate will also double. If it's second order, if you double the reaction, the concentration will get multiplied by 2 squared. And then if you triple the reaction, then, if it's third order and you double the reaction, the rate will increase by 2 to the third, which is 8. This is 4. So basically, it's the order that it is basically the exponent of the number that you double the reactants by, if that makes sense. In the case of this reaction, when B was tripled, then the reaction rate increased by a factor of 9, which is the same as 3 squared. So since the reaction rate increased by the square amount of what the reactant increased by, then we know that this would be second order. Also, another thing I forgot to add is if the reaction is 0th order, then if you double the concentration of reactants, then the rate will not change because 2 to the 0th power equals 1. And that means you're just multiplying the rate by 1, which doesn't change. Okay, now we are given a graph, and it's asking us for the rate law for the reaction. First thing you want to do is ignore the chemical equation that they give you, because that does not matter when you're looking for rate law. Remember, the rate law formula is K concentration of A to the power of whatever the order is, and then concentration of B to the power of whatever order it is. So the first thing you want to do is find 2 rows where the concentration of one of the reactions stay the same, while the other reactant, which is the one that you're trying to find, it changes, and then you compare the rates. So let's start with reactant A. We can see that these 2 rows, the concentration of A doubles, while the concentration of B remains the same, and that quadruples the reaction rate. Since we just found that when the concentration of A is doubled, then the rate increases by a factor that's squared, then we know that reactant A is second order, and we can plug that here. Now let's do the same thing to find the order of reactant B. So I am actually going to take these 2 rows, because the A concentration stays the same here, but the B concentration doubles. So we're going to go up this way, and that is a times 2 factor. And then when we go from 0.0025 to 0.005, we know that that's also times 2. And this is easy. So if they change by the same amount, then you know that the order of reactant B is 1. So we know that B is first order, and that is your final rate law. Alright, this problem is kind of long, but I'm just going to go through it really quickly. We first want the order of the reaction in respect to ClO2. So we look right here, which column changes while the other stays the same. Well, 1 and 2 do. And we take this one, which goes up by a factor, or it multiplies by a factor of 3, while the rate, we have to divide that. Oh, I'm going to do the math. Okay, so I divided the 0.0248 by 0.00276, and I got around 9. So let's just say it multiplies by a factor of 9, and then we know that ClO2 is second order. Now it's asking for the order of OH minus, and we're going to take, let's see, these 2 rows, because this one stays the same. ClO2 concentration stays the same, while the OH concentration changes. So we know that when the concentration of this one changes or multiplies by a factor of 3, this one you have to calculate it, but it also increases by a factor of 3. So we know that OH has a first order. To find the overall order of the reaction, you add up the two orders of the reactants. In this case, 2 plus 1 equals 3. In order to find the magnitude of the rate constant, you use our original equation, R equals K, and then this time we know it's KClO2 to the second power, since it's second order, and then times the concentration of OH minus to the first power because it's first order. To find the numerical value of K, you want to plug all the information in for one specific experiment number, so keep it constant. In my case, I will just use a first experiment. Alright, I just plugged the experimental values into the equation, and now all you have to do is algebraically solve for K. I solved it using the calculator, and I got K equals 229.63. And looking at the answer choices, E is the closest. Alright, the last question is, for first order reaction, the plot of blank versus blank is linear. So this you honestly purely have to memorize. It is A, because the plots of first orders, it's always ln of A on the y-axis, and then versus time. That is linear. Alright, pause for a second to read the next question. So they want us to find the rate of this possible mechanism, and it says that the first step is a fast step, while the second elementary step is a slow step. And we always base the rate off of the slow step, no matter where it is. But in this case, since there is 2 elementary steps and the slow step isn't the first one, we need to make sure that our rate reaction only includes reactants and not any intermediates. So let's see. NOBr gas plus NO gas turns into 2NOBr. Honestly, we don't care about the products, but this one is a problem because NOBr is a intermediate that you get from the first reaction right here. You get NOBr from the fast step. And remember, we don't want any intermediates in our rate law formula, so we have to take this NOBr and this NOBr2 and translate it to basically these two reactants, which are a part of the equation, and that is correct. So instead of writing the rate law equals the concentration of NOBr2 and NO, we change this part into the rate, or the concentration of NO times the concentration of Br2, times the concentration of NO, which is from here, and you get K concentration of NO squared because you multiply all of them, and Br2. And that is your rate. Okay, last problem. We are given this 3-step equation which has a slow step on the second step, and we're trying to find the rate law equation. So since we know that it's based off of the slow step, then we can do N2O2 and H2. But N2O2 isn't even a part of this overall reaction. So you want to take this, which was an intermediate from the first step, and we're going to instead replace N2O2 with 2NO. So now we rewrite it as NO squared H2. And that is basically our rate. Okay, one thing to make sure that you keep in mind is that you can only do this, which I'm pretty sure is what you're going to get on tests, but you can only do this if the step that you're taking it from is a fast equilibrium. So seen by this forward and backward arrow. And this is because that if you want to cancel out the intermediates and replace it in its rate equation with the reactants, then you have to have it be at equilibrium and switch back and forth. Also, this got cut off. It's supposed to say fast equilibrium right here. Okay, that's all for this video. Thank you for watching and good luck.